Hello everyone, welcome to this video. In this video, we shall be talking about a problem based on IIT-JAM paper 2019, which is of 2 marks, and this is a multiple choice question, right? So they are asking for this particular function, which is a function of 2 variables x and y. It has a saddle point at which among these 4 points. So now, if you remember, what is the roadmap to solve this question? How do you reach at various points which either are the saddle points, the local minimum or the local maximum? So for that, first of all, what you do for your given function f, you calculate the first derivative with respect to x partial, and you calculate the partial derivative with respect to y. Then you substitute these two equal to 0. Then whatever are the equations, you solve these equations and calculate all possible points. Those points are termed as the critical points. So you are to check at these critical points what is the case. So for that you use the second derivative test, right? So you should also know what is the second derivative test. So let me remind you that also. For the second derivative test, what you do, you calculate the double derivatives of this given function. So with respect to x, with respect to y, and the mixed derivatives with respect to xy or with respect to yx, whichever you wanted to calculate, right? So after doing that, you define the term capital D, which is nothing but the second derivative with respect to x multiplied by the second derivative with respect to y minus this second derivative, the mixed second derivative whole square. Now you have various cases. For the first case, if your this quantity D, that is positive quantity, and the second derivative with respect to x calculated at the point with the point which you are evaluating, right? So let me call that by x naught, y naught. So if this thing is also equal to 0, we have a local minimum. This is the case. Then in the second case, if this D is positive, but now your first this second derivative at the given point, at the point at which you are evaluating, is negative, then you have local maximum. In the third case, if you have the value of D as negative, then that point is surely a saddle point. And if at any case you obtain the value of D is equal to 0, you may not conclude anything from that. So we'll say we cannot conclude anything. Right. So here in this particular case, we are interested for those points where the value of this D is negative. That would result in the saddle point. So let's start with our function. So our given function here is this f of x y, which is given to be x cube plus 2xy plus y cube, right? So the first step is to calculate the first order partial derivatives. So what would be the first order partial derivative with respect to x? So it would be 3x square plus 2y, and the first derivative partially with respect to y, it would be 2x plus 3y square, right? The next step is to put both of these derivatives equal to 0. So you will get two equations. So your first equation is 3x square plus 2y, that is equal to 0, and the second equation is 2x plus 3y square, that is equal to 0. Now you solve these two equations and evaluate what is the value of x and y, and you list all the points which are available by solving these two equations. So you may proceed by any of the method that you already know to solve two simultaneous equations. So here what I'm doing, I'm evaluating the value of x from this equation, substituting it into this equation, so that I would have the term 0, or basically it would be 3 into 9y to the power 4 by 4 plus 2y is equal to 0, right? So it would be 27. I could take y common from both the terms, so 27y cube plus 8 is equal to 0. So from here, one value of y is 0, and the other values of y, what could be that? So from this equation you may see that if you substitute y is equal to minus 2 by 3, you will get the answer as 0. So this is also one of the value. So these are the only two real values that you obtain from these two equations. So corresponding to these values, what is the corresponding x? So your x in the first case would also be 0, therefore your point would be 0, 0. Another point would be this is when y is 0. When y is equal to minus 2 by 3, in that case your x would be minus 3 by 2 minus 2 by 3 whole square. So x would also come out to be minus 2 by 3. Therefore the second point would be minus 2 by 3 and minus 2 by 3. So these are the only possible points where you would have the local maximum, minimum, or the saddle point, yet we do not know. So that means out of these four options, you already have this option and this option ruled out, because that does not come under the critical points, right? So now we have to apply the second derivative test onto these 2 points. For that, you are required to calculate the second derivative with respect to x. So let me rewrite the first derivative and second derivative again. So your first derivative with respect to x, it was 3x square plus 2y, check that. And the first derivative with respect to y, it is 2x plus 3y square, right? So when you differentiate this one partially with respect to x again, what do you get? You get 3x. When you differentiate this partially with respect to y, what do you get? You get 6y. And when you differentiate either this partially with respect to y, or you differentiate this partially with respect to x, you are going to get the same value, that is 2, right? So here let us first check for the point 0, 0. At 0, 0, what is the this second derivative? Its value is 0, x, y, this is 2, and this is 0, right? So that means one condition is this one, this is equal to 0. And moreover, we are to check d. D is f of xx into f of xy minus, f of xx into f of yy minus f of xy whole square. So in this case, it is 0 into 0 minus 2 square. So that means it is minus 4. So you see, this is a negative quantity, right? So therefore, the point 0, 0 is the saddle point. But for the sake of completeness, so that means your option A is correct over here. But for the sake of completeness, let me also talk about this point B, which is minus 2 by 3 comma minus 2 by 3. So let us calculate for the point minus 2 by 3 and the point minus 2 by 3. So here f of xx, what would be that? It was 6x, right? So 6 into minus 2 by 3, which is minus 4. F of xy, it was constant, so it would be 2. F of yy, its value was 6y, right? So according to that, it would be 6 into minus 2 by 3. So again, it is minus 4. So you see here, f of xx, that is a negative quantity, right? Now let us also see what is d in this particular case. D is f of xx, f of yy minus f of xy whole square. So here the value of f of xx is minus 4 into minus 4 minus of 2 square, right? So it would be 16 minus 4, so that would be 12. So which is a positive quantity, right? So here in this case you obtain D as positive, and this second derivative with respect to x is negative. So that means this is a case of local maximum. So this point minus 2 by 3 comma minus 2 by 3 is a local maximum where the function has a maximum value. So according to the test, because D is positive and the first derivative is negative, right? D is positive and the first derivative is negative, therefore we have local maximum. However, at the point 0, 0, we obtain the value of D to be negative, therefore that point came out to be a saddle point, which was asked in this particular question. So according to that, our option A here is the correct option. So I hope you understood this question. Well, that is it for this video. Thank you for watching.